Users Group, May 2007 meeting. We have a wonderful presentation for you on building scalable, reliable web services using open source technologies. So let's learn how to make soap wash our websites, I guess. So please give a nice warm welcome to Brett Thomas.
So I have to apologize first of all for my operating system faux pas here. I was a very loyal Linux on ThinkPad user for most of a decade, but I finally decided to give BSD a shot here. So I'm Brett Thomas. As he said, I'm CTO of a company called Vindicia, and we do payment management stuff for digital merchants. But that's not what I'm here really to talk to you about tonight. I'm going to talk a lot about open source stuff like Perl and Apache and Postgres and things like that, but most of what I'm going to talk about isn't actually directly tied to any one technology. And so, you know, if you want to use Java instead of Perl, a lot of what I talk about is still going to be germane. If you want to use MySQL instead of Postgres, I mean, it's all pretty much still going to work. I think there's a number of competing open source technologies these days that are all good enough that you don't have to work around their limitations anymore the way we might have had to a long time ago. So, before I really get into the meat of it, I thought I would tell you a little bit about what my experience is, so that hopefully you'll have some idea why you care what I think about making reliable open source websites. As far as I know, there's not a college class on this stuff, and if there is, I certainly am far too old to have taken it. I think that there's a lot of opportunities out there in the open source world that people are missing, but I also think there's a lot of challenges people aren't facing up to, where there are things we can do with open source that we can do more reliably and less expensively than we can with commercial software, but you end up trading, you end up making trade-offs, and there's new management choices that you have to make. So I started out working in OS2 and C++ for large companies, and learned a lot about how you do basic enterprise software development, how you get 30 people, you know, to work on the same project and have it work, how you do version control, how you do configuration management. Learned a lot about how to manage software back in, say, the early 90s, and I think we live in a very different world today, and we may not have totally adapted all of our process to that. I got interested in the internet pretty early because I had been involved in bulletin boards, and when bulletin boards kind of started to implode in the early 90s, I started reading about the internet and said, hey, maybe that's kind of a replacement. And started reading a little bit about Linux, I think maybe in Dr. Dobbs' journal in 1993, and I had a shell account with a local Unix provider, and so I downloaded Slackware Linux 0.99 something, and I remember I kicked off the download of all the disks and went to work, and I came back and it was still downloading, and I eventually got it all up and working. I got Eileen Frisch's Essential System Administration because I had absolutely no idea what I was doing, and kind of blundered around, turned my shell account into a slip account, and started connecting directly with Linux. And then I started messing around with X, and that was back in the days when you had to do all your monitor timings by hand, and there were all these dire warnings about blowing your monitors up. And I spent a very stress-filled summer afternoon, one afternoon, trying to get my generic monitor that had no entries in the timing listings trying to work, but finally did, and I got Mosaic, the first web browser up. Not long before Comet Shoemaker Levy 9 hit Jupiter in early July. I don't know if anyone remembers that from '94. And I remember I went on to JPL's webpage, which was one of the few web pages in existence. And I have to say, I Googled for it, and they still have it there, JPL's website, with its top 5% of the web badge on the bottom. And I went there right after the impact, and I downloaded a picture of the comet hitting Jupiter. I said, wow, that's really cool that I can do this. And I got up and I walked in the other room, and John Holleran, the CNN science correspondent, was standing outside JPL with a microphone and was saying, we understand that the impact has occurred, but we don't have any pictures yet. And I said, you know, I think this internet thing might go somewhere. Like,
It was 94?
Yes. And because I was sitting there in Colorado Springs and I had pictures and he was at JPL and he didn't. So not long after that, a couple of years, a colleague of mine said, you know, I know you're kind of into this whole encryption thing. I have my aunt's vice president of engineering at a company called Pretty Good Privacy out in California. Do you think maybe you'd be interested in working on that stuff? And I said, well, first of all, I was still working in OS2, and I don't think it took a real genius to figure out that OS2 wasn't going to set the world on fire in 1996. And I've been using PGP since the early 90s, and so, you know, it was a real easy choice to say, yeah, I think I'm going to come out here and give that a shot. So I did PGP 5.0 for Windows, and we were a small company, and nobody really thought much about what needed to be done other than what had to be done. And we came out with 5.0, which broke compatibility with the previous 2.6.2 version because of patent licensing issues, in a real foreshadowing of kind of what's going on today. So we kind of got out the 5.0 Windows and 5.0 Mac, and we were a small company, and somebody said, you know, it's not compatible with previous versions, and we kind of need a Unix version, I guess. So I volunteered to do the Unix version of PGP 5.0, which honestly wasn't the best piece of software ever because we didn't put a lot of effort into it. We also did a key server product, and I was tasked with doing an administration interface for it. And that was back in the days when X widgets were a nightmare for free software. There was no good free software X widget. There was implementation. And so I decided to just go around that and write the admin interface using Apache and Perl CGI Venice. And so that was kind of the beginning of my introduction to this world. And at PGP, I learned one really big idea, and that was don't make things hard. Because when you make things hard, you waste your time, and you waste the time of whoever has to undo whatever hard thing you did. They should either be impossible or they should be easy. Don't delude yourself. So after I was done with PGP 5.0 for Unix, we got purchased by McAfee, which was called Network Associates at that time. And I was retasked with making an email policy plugin for Microsoft Exchange. So I went from writing PGP 5.0 for Unix freeware to help people encrypt their messages and protect their privacy, to writing a Microsoft Exchange plugin to make sure that if you emailed an encrypted message from your work account, that it was also encrypted to your boss. And I wasn't a very motivated employee at that point. And so when a friend of mine left to found a company called, at the time, Good Noise, and then eMusic, and said he wanted me to come along, I was very happy to do that. That was another pretty easy decision. Gene Hoffman was my partner at that time. It still is, actually, in my new business. And he was one of the co-founders of PriveNet, who did the first cookie cutter and the first ad blocker for Netscape, and then got bought by PGP. And it turned out he liked music, and he said, hey, why don't we start a company to sell music online? This was back in 1998. And I've been running my own home domain on Linux for a few years, and I said, hey, yeah, no problem. I can run a website on Linux. I can figure out how to do that. That should be no big deal. You know, of course, up to this point, I only developed software. I've never actually done anything operationally, but how hard could that be? So very shortly, I was out explaining to venture capitalists in 1998 about how I was going to be running everything on Linux and Apache, and about how that was really a good idea, and no, I didn't see why we need to go out and spend a lot of money on a bunch of some hardware right now. Right now, you know, everybody thinks that's that you don't have a lot of trouble making that explanation, but back then it was a tough sell. So our business model was about to pay artists for the right to sell their music, and then we distribute them online in MP3, not using any DRM. Remember, easy or impossible, not hard, because DRM is hard. Our business was selling at 99 cents an album, 99 album, 99 cents a song, 9.99 album. I think it's a really good business model. Someone should try it. We turned ourselves ended up turning ourselves into a subscription model, which is actually how I ended up getting the rebuilding business, is what I do now. The other thing we did, kind of from an open source perspective, was at the time Winamp was was pretty big, but it wasn't as dominant as it was going to become. And we were worried that if we were trying to sell music to our customers, that they were going to be worried that they wouldn't be able to play it. And so I said, well, hey, why don't we make an open source MP3 player? And then that way, everyone can always be confident that no matter what, they'll be able to play their own MP3s. And at that time, there wasn't an open source MP3 player. All the MP3 players there were freeware ones, but there was no open source ones. So we founded a player called Freeamp, and we actually negotiated a patent license for Freeamp for the MP3 player, which, as far as I know, it's the only open source player, and I believe the only freeware player that had a patent license. We tried to get Red Hat to include it in the operating system, but they said, well, you know, XLM amps are really good Winamp clone. You know, we don't want yours. We weren't trying to be a Winamp clone. We actually wanted to integrate searching and music, kind of like that iTunes thing. So we didn't have a good argument for that. Of course, what happened was, a few years later, Fraunhofer sued Red Hat because they didn't have a patent license for XLM amp, and now they don't distribute an MP3 player at all. On the more mainstream business side of things, which is where I get into really the experience that I got on this germane to my talk, we used open source technologies. We were able to build up a site that serves 70 megabits a second at its peak. We had a terabyte of storage, back when that was a lot of storage. We did it all for very little money, especially for the time. We did end up using Sun and Oracle for our database, and I'll get into a little bit why we made that decision at the time. Although at the time, MySQL was, Postgres wasn't mature enough yet, this was about 99, to really run on. And MySQL was still stuck in a world of table locking only. And so when you tried to build too big a site on it, you eventually hit the point where everything just intermeshed and you couldn't really keep it going. We used to joke, and we weren't entirely kidding, that how much we loved something in our system was inversely proportional to how much we paid for it. And that did not include in any way the value of the money. You know, the Linux and the Apache and the stuff we got for free was the stuff that we never had to think about. And the stuff like the Oracle and the Sun that we spent all this money on caused us absolutely the most headaches. So I talked about my the big lesson I learned from PGP. I learned two big lessons at eMusic, and the first one doesn't really take a rocket scientist to figure out. That is, open and free beats closed and expensive. The other thing was that there's no such thing as a system that never fails. We spent a lot of money on a Sun Enterprise 4500 to run our Oracle database after we gave up on MySQL. It had all this stuff in the hardware to make sure that it never, ever, ever went down. It had redundant power supplies. It actually had this really clever multiprocessor system where you could literally unplug a processor while the machine was on and replace it in case you had a processor failure. That was the level to which they made sure that this machine was never, ever, ever going to go down. In the first 6 months, I had a backplane failure, which is supposed to be once in 120,000 hours kind of failure. But when the backplane goes out, the machine goes down, because you can't have a redundant backplane on that architecture. And it took the website with it. And so we started architecting everything to figure, well, okay, I guess we'll have to work around that. And once you start saying, we've got to work around that, you start saying, why am I spending all this money for this redundant hardware when I have to work around the fact that this is going to go down anyway? Maybe I should just buy really cheap stuff and design it so that I don't care when it fails. So I'd like to take you now through the technical evolution of the eMusic site, and some of the problems we had and what it taught us. While eMusic is a website and not a service, the basic fundamental architecture at the network level isn't very different. And it's actually not very different at the application level either, because when you're writing into a web server, you're usually putting some code, say through mod Perl, plugged into a web server. And you do very similar things when you're doing services. You still have all these redundant servers that are out there actually handling connections, doing connections back to databases in order to pull the data, that sort of thing. And it also allows, giving a talk like this, I don't know what everybody's experience level is with the various technologies that we use. And so I apologize if anybody already knows some of the stuff I'm going to talk about here to introduce. So in preparation for this talk, I carefully went back and reconstructed the initial design that I, with no operational experience, came up with for the music design. As you can see, it was pretty simple. It was pretty obvious that we could improve on that. So the next step was to break that out so that we had a web server and a database server. But not long after that, we actually raised some money. And I started hiring people who knew actually how to build this stuff. And one thing I had not heard of before this was the concept of a load balancer. And the idea from a web services or from a web server perspective is that a load balancer can sit out here in front of the web server, and it can take in connections, and you can have multiple web servers that then go out and talk to a single database. And so that provides you both scalability and redundancy on your web servers. Now, nowadays, there's a product called Linux Virtual Server that does that in open source. But back then, again, back in 1999, that was just getting started, wasn't ready for prime time, so we had to go with Cisco load balancers at the time. So this was the basic architecture that we came up with. I will confess that the computers behind the back end were not crazed, but I like the icons. Where you have multiple web servers here that they connect on the back end network to, in that case, a music main store and an Oracle database. In order to handle access control information and log who was downloading what. The really nice thing about this sort of design is that it scales along the way without being replaced, and it scales very smoothly on cost. A lot of people talk about scalability. To define really what we're talking about, there's two main attributes that we're usually concerned about on scalability. The first is that you should be able to get to a high total number of transactions without replacement. So you never want to get to the point where you say, wow, we just, it fell over, we can't do it anymore. We need to go to a completely different technology and start over. The other is that it should scale smoothly. And very often people talk about what's called the power plant scaling problem. And the idea is that if you imagine the power plant costs $500,000, or $500 million, and it can produce 500 megawatts, if you want to produce 500 megawatts, one power plant is sufficient. If you want to produce 501 megawatts, you need 2 power plants, and so that doubles your cost. And certain attributes of systems like web servers that are behind load balancers scale very smoothly because you just keep adding small incremental costs and you increase your capacity. Systems like databases tend to scale a lot more like power plants because you tend to have a very big system back there, and then you take your very big system and you get to a point where it just doesn't work anymore and you have to replace it. Sorry about that. So, in the conventional design, as your web servers scale, you just keep adding. It keeps talking to your database. It depends a lot on what your actual back-end application is. If you need your front end to do a lot of computation, then you're able to keep adding systems there, and it keeps working well. But if mostly what you're doing is talking to the database, then the database ends up being your big lump. You can imagine a world where you could have lots and lots and lots and lots and lots of scalability, but if every one of those web servers has to talk to the back-end database, then you end up with real problems. And that leads me to something that almost everyone knows in software development that I personally think is wrong. And that is, I was taught this a long time ago, do everything in the database. And the theory behind this is that communication with the database is very expensive. And therefore, if you do all of your work in the database, you minimize the amount of transfer of data you have to do back to your application. And it's not hard to imagine why database vendors think that you should do that. But the problem is, in the real world, the database is the least scalable component that you have. So you should be minimizing the use of it as much as you can. Don't calculate things in it. Don't offload stored procedures to it. In some applications, you may not want to do joins in it, or even constraints. If you double the load on your application server, you just get twice as many. If you double the load on your database, you have a big problem, especially if you can't just buy a bigger one because you already have the biggest one. We use databases for 3 things that we can't get out of flat files. Relational association of disparate data. Actually, hold on just a moment. I've gone off my screen. In many cases, your data isn't relational. and it doesn't have serious transactional integrity issues. It is either centrally generated or it doesn't have conflicting changes in multiple places. And it doesn't have to be the same everywhere. And so, databases are designed to attack 5% of your enterprise problem, which is you have a little bit of data that has to be the same everywhere all the time. And there's a real tendency that once you have this really cool, neat tool, that's the database, to apply it to everything, because it can do everything. For example, consider e-music. We rip gigabytes of music, and it's metadata, and we store it in the database. But, not the music, the metadata. But the thing is, the metadata never changes. I mean, it's not very often that you retroactively retitle an album. And when it does change, it always changes in one place. It's not like we have a bunch of users out there on the edges that are making these changes. There's a centralized place where it happens. And even if it did change, and we fixed a typo or something, if it took 15 minutes or a day to get fixed, that's probably perfectly acceptable. So why store it in the main database? We could have a centralized music store and distribute the metadata to each of the individual web servers as a tarball every night. Similarly, the big data that we generate during the day in music is information about who downloaded what, because we have to pay our artist royalties. We can track that, but there's no possibility of conflict there. If somebody downloads something twice, they downloaded it twice. It doesn't mean that we need to back out any changes or anything like that. And it's not timely. The most we would ever have to report on that is daily, and probably get away with weekly, realistically. I mean, I'm sure the marketing guys would probably say otherwise, but they could probably deal with it if the system that was constrained in the system. So we could probably just write that to a log on the web server if we wanted to. And the other big thing we need to know is whether somebody has access, because you have to pay for the access, and so we need to be able to tell that in a timely fashion. And when you first think about it, yeah, okay, that sounds like something we need a database for, because it can change in customer service, it could change in the billing application, it could change if the customer went to his my customer page and canceled. And when somebody does get cut off, that probably needs to happen everywhere, like immediately, not take a couple of days to happen. But there's already a specific system out there that does something very similar to this, and it's called LDAP, the Lightweight Directory Access Protocol. You can put passwords in it. There's OpenLDAP, which is a nice open source implementation of it. LDAP is a little bit of a pain to learn, I'll confess, if anybody's ever messed with it. It's not the most fun application in the world. But once you remove those three basic things the web servers start doing, you start going, maybe my web servers don't need to talk to the database at all. Maybe my database doesn't need to be a part of my scalability in any way. Because I gotta tell you, how nice would it be if you're running this website and you said, yeah, the database went down, it's been 6 hours to come back up, and nobody cares. So obviously not everything works this way. I wouldn't want to run a bank on it. I was able to get away with it in my current business when we first started, but we have unfortunately moved towards more real, unfortunately for me, more real-time applications. And I have, in fact, actually had to implement databases on the back end that are more reliable than that. If you do have systems, data that needs to be changed everywhere and be the same everywhere, all at the same time, I gotta be frank, open source doesn't do it today. There are people who are working on it for Postgres, but if you have a widely disparate enterprise, I'm not aware of any technology that does that yet. Oracle Streams is the conventional wisdom on it. It's expensive, it's hard. My advice to everyone is try to avoid those kinds of situations if at all you can.
Sorry, are you talking about replication?
I'm talking about replication where you are having master-master situations, especially geographically disparate master-master situations. There is, and I'll get, when we talk a little bit more, when I talk a little bit more detail about some of the specific technology later, I'll talk a little bit about sloaning under Postgres, for example. But that it is one of the few places where the open source world still just has not completely caught up to the closed source world.
So when you talk about using a log,
Mm-hmm.
I mean, does that mean that you just piggyback on the log mechanism that's in the system, or Or are you just using that as sort of meaning we just wrote out a flat file?
Yeah, exactly. So what I was suggesting there is that in this kind of world, all you have to do there is you can write that out into a flat file on the web servers, and then on a nightly basis, offload this to another system that will then import it into the database. And again, you have to be careful when you do that, because if you have conflicts, then you have problems. But a lot of data doesn't have conflicts. If you're noting that somebody did something, that's not going to conflict with anything else.
You have the problem that you can't add new customers, probably, because that's actually your database, right?
Well, no, again, that would be, and I noted it right here on the LDAP server. And so ideally what you'd be doing is you would have some mechanism for going through the LDAP server in order to do that.
Right, but usually you're collecting more information than the LDAP server.
Yes, yeah, but as far as the primary access,
Okay.
that tends to be what's timely. And so it's quite possible to be adding that to the LDAP server on a timely basis, and then also in a less timely basis, again, writing that to the log file and exporting that back to the, and it's pretty easy to write a generic mechanism to process those log files, pull them back into the web servers. You just have to make sure, again, that, any case where you have the possibility of conflicting data, then you either have to have some mechanism to ensure that the data can't conflict, or have some mechanism to actually go back to the database and ensure. But the more you can avoid doing that, the more you reduce that load on the database. So now I've done the basic overview of how systems like this work, and I do recognize that my basic suggestion of not using a database is a bit more radical for most people. But I'd like to go through some of the specific technologies that I recommend and that I have experience with. And again, I'm not necessarily saying that these are the only technologies that work. It's just that these are the technologies that I've had experience with over the past 10 years. There was a fellow at eMusic named Neil Overman who came up with the acronym RALPH to describe this philosophy, which is the redundant array of Linux peripherals and hardware. He said that the R stood for random, but I like my acronym better. So, from a core perspective, obviously Linux, especially here. Apache, I'm not aware of really an alternative to Apache if you're going to be running on Linux, a realistic one, even if you wanted to pay for someone. It handles the connection, it handles the encryption, it handles the data transfer. If you're not building a website, if you're building web services, then I think you need to be looking at SOAP as the protocol where you're doing that transfer. I don't know how familiar everyone is with SOAP here. SOAP stands for the Simple Object Access Protocol. It's arguably a little too simple for some stuff, maybe a little too complicated for other stuff, but it's really generically a very nice way to have cross-platform services that you make available to third parties especially. It's also useful in-house too. In SOAP, it's usually broken up into two pieces. The communication itself is a set of XML that describes what functions are being called, what data is being transferred back and forth. There's usually also another XML file called a WSDL that describes what legal calls are and what legal data looks like for your application. In languages like C++ and Java, where you have to know what your classes look like beforehand, the WSDL is absolutely essential, because the WSDL explains to the language, these are the classes that I'm doing, these are the methods that I'm calling, so that you can even compile it.
Were you using SOAP back in 99 or using
No, we were not using, eMusic did not use SOAP. So just to be clear, when I was going through the eMusic thing, it's because that's something I had an intimate experience with, and it is a the physical architecture of it is very similar. The SOAP piece of it, however, from an architecture perspective, can fit into those each of those web servers. You can certainly be running SOAP and have almost identical physical architecture for a system where you're using SOAP to transfer data. No, in fact, actually, I mean, this is one of these great things where 15 years ago, there's no reason you couldn't have done this. I mean, there's not any great breakthrough in technology that allows SOAP. It's just that you would have spent 2 years defining SOAP before you could do anything else. And now you just sit down and you plug it all together.
So what language do you use to build the application?
Personally speaking, I use Perl, and I'll be talking about this. I'll be talking about that a little bit more later, and giving some small examples. But the great thing about SOAP is that it's completely cross-platform, and so since you're simply defining the XML and the data types, there are SOAP libraries for every major language and every major platform, and so. My new business now, we run a system where other merchants connect to us, and we run it using Apache and Perl. But we have clients that run on Linux Apache, that run on Linux PHP, that run on Windows COM in C++, in Java on various languages, all that. And it is just nobody cares what anybody else's platform is. It's very smooth that way. And if your languages are completely, if you have the same language on both ends, it's just magic. I mean, it really can just work without you even thinking about it. And I'll again get to that a little bit later. On-the-fly languages like Perl don't necessarily need WSDLs because they're able to just pick up the classes, pick up the functions, and they just make it up as they go along. But you can use the WSDLs in those languages in order to make sure that your system is correct, as opposed to making sure that you can at least compile it to begin with. So the way SOAP the way SOAP works, and it kind of, you arbitrarily decide one is the client, one is the server. You have the client here can make calls to the server. The server probably has a database on the back end it pulls data out of. I realize that's a very simple little picture, but that's really about as complicated as the network architecture is on the smallest set of SOAP. This is what a very small client looks like using SOAP-like in Perl. And I will assume you have basic Perl functionality on the client side. You literally just instantiate your SOAP object. And then you make a call right here to the SOAP object, and that call maps to a subroutine on the server side. It executes it. You can take an arbitrarily complicated Perl object, Perl class, so we have the mythical person class right there. It packages it all up in XML and returns it across the wire. And you run the client side on one computer, you run the server side on another computer, and it all just works. So generally speaking, all of that on the server side, and I'm sorry, that's a very good point, I should have clarified that more. On the server side, you're usually doing all that configuration piece in Apache. And so there's a configuration element to Apache where you say, basically if you get a request to this particular address, you hand it off to this Perl handler. And the Perl handler then, SOAP-like comes with some default ones, then dispatches that off to your actual Perl code so that it knows where to find the method in order to execute it. So, but this is the only code you actually have to write. So, and by the way, again, anyone who knows Perl, I highly recommend pick up a copy of SOAP-like off the CTAN, take a look at it because it's very easy to get your basic servers going, and it's really just amazing. The first time I did it, I was just like, wow, I can't possibly believe it's that easy. Assuming I haven't talked you out of needing a database at all, you will probably need one. I personally have experience with Postgres. I do want to give full disclosure. After 4 years at Vindicia, I was finally forced to migrate to Oracle, but it was not anything to do with Postgres. I had a very, very large Fortune 500 company who was going to pay me a lot of money, but they stipulated that we had to run Oracle because they didn't trust Postgres. And so I couldn't really take the cost of running both databases and maintaining both of them. So I did finally, literally like 2 weeks ago, bite the bullet and then move off of Oracle. But it is certainly no knock against Postgres that we did. Postgres has a technology called Slowney, which will allow you to replicate master-slave failover so that you have one database and you have a backup. When the first one dies, you can replicate over to the other one. That works great within a single stack. If you're planning on using it, though, I recommend using it from the beginning. It's very hard to retrofit because it has certain requirements about things like unique keys and naming of things and different things like that, that if you try and retrofit it in, can end up making it a lot more difficult than if you just do it the first time. The problem, as I alluded to earlier, is that the open source world does not have a solution yet for distributed database replication. There is what's called the split stacks problem. And the idea is that if you have two stacks right here connected with a monitoring link, and you have remote systems that are connected to it across the internet, it is possible for this mirroring link to go down, but this system to still be able to talk to both of them. And the problem is if this mirroring link goes down, that means all the network connections between these guys are down, and this stack can't tell the difference between a network failure and the primary stack going down. And so you end up having both of those databases live at the same time, and you end up writing conflicting things to both of those databases, and that is in fact why this is a very hard problem that the open source community has not yet been able to totally tackle. I think it may be possible using multiple VPN routes thrown all over the internet to make it so that your secondary stack can figure out whether your primary stack is dead or just having network problems, but I haven't actually implemented it, and I don't think you could really prove that it would work. If you give that a shot, let me know, because I'm interested in how it works out. Again, the conventional wisdom right now is go with Oracle streams. If anyone else knows different, I'd love to hear about it, but I haven't come up with anything better. I also recommend going with Linux for routers and firewalls. Why should you pay Cisco to manage Linux? You know, probably worse than you can. You can do arbitrarily complicated things like traffic shaping with the tools. It's what you can do with Linux routers and firewalls is actually pretty remarkable, although as with a lot of stuff, what you end up losing, what you end up saving in support cost and initial expenditure, you may end up spending in documentation time and trying to figure out how exactly it all works. I think you should probably at least double up your routers. There is a wonderful tool called Keep Alive D that allows you to have two routers that are running next to each other that have the same public interfaces, the same private interfaces, and then a heartbeat line between them so that it can tell the difference between when the box goes down and when the network gets cut. And then this box can actually take over the IPs of the other box, and that way it's completely redundant. One interesting thing that brings up is reliability in Ethernet cards, because if you take this basic approach that I'm suggesting, you're going to replace a bunch of small, expensive systems, or a bunch of large, expensive systems with a whole lot of small, cheap systems. And a lot of these small, cheap systems, like these routers, each of these guys has to have 3 Ethernet cards in order to handle the public, private, and heartbeat interfaces. One of the good things about, again, living in the future is that Ethernet cards are really cheap. I remember my first Ethernet card cost me about $100, if I remember right. It was 10 base T, and it wasn't a very good one. The most expensive Ethernet card you can buy now, if it's 100 base T, is probably less than $20. But the bad news is because they're really cheap, they're not very reliable. I have at Vindicia right now 80 boxes in production. I'm going to conservatively say that I have something on the order of 200 Ethernet interfaces deployed. Mean time between failure on Ethernet cards in my organization is pretty bad. That's my biggest failure point, is Ethernet cards that fail, because I just have so many of them. Doesn't happen very often, but that's been my experience over the past 10 years. It was the same with music as well. So what I like to do is throw an extra Ethernet card in there, because if you're working and if all of your failover is working, you don't really care that it went down. You just don't want to have to pay somebody to go back out there and replace it. Actually, the most recent Ethernet card failure was I had a router in Salem, New Hampshire go down on Christmas morning. but I had given everyone else the day off because I figured nothing much was going to happen, and I was the one who was on the tech support call.
Sorry, you put one extra.
So the idea is, yeah, put an extra Ethernet card in.
And how does it know?
It's on automatic. Okay, somebody still has to go out there and plug it and unplug it, but usually if you're co-located, you can get your co-location facility staff to just go do that.
Sorry, plug it or unplug it, meaning?
So you've got three. In this interface, you have 3 Ethernet cards. Okay, one of in a spare. One of them goes down. Somebody has to go out there, pull a plug out of the one that broke, plug it into the one that didn't.
Oh, so it doesn't do an automatic failure?
No. No, but the idea
I was
is.
wondering, how does it get to know that it should be the dormant public
Right.
interface or the?
The idea is, especially if you are in a world where you're shipping routers across the country to different co-location facilities and things like that, like I've gotten into recently. You know, if there's a failure of the category of the card went out, that usually means either shipping a new box out, sending someone out to fix it, but you can usually get a tech out there to plug an Ethernet card, unplug it, and plug it back in. So, although I do highly recommend that you reboot the box after you do that, and that way 2 years from now, when it finally does reboot and you forgot to actually get the configuration right, you're not going, why did that come back up?
So do you have scripts that reconfigure it when that happens?
No, that's what I mean. So the idea would be you would change the etc CD by hand at that point, and then, but be sure to reboot it because otherwise you'll just change it live, make a bug in the RCD update, and then you go, hey, why didn't that work 2 years later when it finally reboots?
So do you find that the Ethernet built into the motherboards is a lot more reliable than ones that are on?
Yeah, no, actually I do find that. I'm not sure I've had an Ethernet ever go on the motherboard. But again, on those routers, you know, you usually end up throwing a couple Ethernet cards in there at least. So, especially when you start talking about routers that are then talking to a private, you know, a couple of private networks and different things like that.
So then how many? You must not have overly large bandwidth needs then if you find that Linux routers do it for you.
In my current business, I will say that I don't. I mean, right now we're running about 3-4 megabits at the moment. Like I said, in the music case, we were doing 70, but we weren't doing Linux routers. So, do you have experience that beyond? I mean, do you have any idea on like what the thresholds would be like?
Well, so at the current business that I'm consulting for, in order to be cheap, they put Linux routers everywhere. And so, you know, for example, they had a gigabit line in their home office as a colo, and they thought, oh, this is great. We could actually, you know, do some really cool stuff using this gigabit line. But
right.
The little dorky, and they were underpowered Linux boxes, but the little Linux boxes they were using only could handle 70 megabits.
Oh wow, yeah.
Right. So,
Well, I've definitely done 100 out of non-Linux, out of Linux non-routers. And I'm absolutely certain that the driver makes a big difference. You know, certainly you can have bad drivers that cause problems. But I will say I've never tried running a Linux router at anywhere near that capacity, so I don't have personal experience with it.
yeah, so then what they actually need is they really want a gigabit
Right.
to the router. You know, so that means behind real
Right. Now, it is important to understand the limitations of your hardware, because a lot of times what matters for your business isn't what the spec is. Because we actually had a specific problem with the Cisco load balancers at eMusic that were spec to do, I think 75 or 80 megabits a second. And we started having bandwidth limitation problems at like 20 megabits a second. And I was going, well, this, you know, like we're so well within spec, I didn't think it was the problem. And it took a very long time for us to figure it out and diagnose it, but it was actually that at eMusic, we had the problem of a whole bunch of dial-up people downloading these 3 megabyte MP3s, and it would take all night. And so we actually saturated the connection limit on the number of concurrent connections long before we saturated the megabits per second. And so, anyway, I guess, as I say, if it were easy, anyone would do it. And actually, I believe I mistitled this. Oh, no, I did not mistitle this. So, the other thing, of course, that you need to worry about is load balancing. And again, I've been very happy, although I've not tried to run it with 70 megabits, with the Linux load balancing stuff. And this is what's known as the Linux virtual server. And I've actually drawn out the diagram here on this one because I've talked to a lot of people who tend to be confused about it. Because you use Heartbeat, which is the keepable IP, between the actual load balancers in this configuration But the load balancers themselves then make the web servers redundant. And so what they do is when a web server goes down, it notices that it's unable to talk to it anymore and it stops sending traffic that way. And the web servers are redundant by virtue of the fact that you have a bunch of them and it just hands each one at different connections as they come in.
So, is it random or is it feedback?
You actually get to choose which algorithm you want. So you can either do it round robin, you can do it by response time, which I think is how most people end up doing it, where you say, all right, you know, whatever server is responding most slowly, I'm going to give you these two. And you can also do it, I believe you can probably do it randomly. So, like I said, we do all of our web services through it right now, because again, you just do web services, connect to Apache, Apache runs your SOAP, and you know, you're done. And it does a really good job as far as splitting it up. Like when I look at the statistics, at least we use, I believe we use the load testing, but it still does a pretty good job of splitting it up among the boxes. So, I hope that I don't have to say this, but if you're using Perl, be sure to leverage the Comprehensive Perl Archive Network, or CPAN. CPAN is a lot of why I run Perl. I mean, I like Perl for itself, but there is no other language out there that I know of that has that repository, and they have a real culture at CPAN of testing. Everything has to be tested. It's very rare when you download something from CPAN and it just explodes. I cannot possibly tell you how many hundreds of thousands of lines we have not written over the past 10 years because of CPAN. I mean, whatever you want to do right now, there is already a module out there on CPAN that does it for you. And it really is just absolutely a remarkable resource, although it brings some additional challenges with us. So if you do this kind of basic architecture, and if you leverage the open source world to pull in those tools like that, like CPAN, that and like SOAP-like, that you don't need to develop in-house, it does open up a number of management problems that we're not used to dealing with in software configuration management. A lot of these things are things that we've had little solutions for over the years. But as with everything else, scale matters. And when you have 3 of something, it's a lot easier to deal with than when you have 100 of something. The 3 big problems that you end up with, again, it goes back to the hundreds of machines that you now have, is the sign-on and log-on problem. That's, you know, when you have 10 systems, you can copy Etsy password around, and that works okay. But it doesn't work okay if you have 200 computers. But again, we get back to OpenLDAP, and LDAP solves that problem. Almost every single open source package out there can be configured to use LDAP for its logons. We use LDAP single sign-on for IM, for email, for the website, for actually logging into the computers. I mean, everything that we've ever needed to do, we're able to configure it to use LDAP, and you change your password and it's done, and you revoke someone's access and it's revoked everywhere, and there's no headache with it, other than the overall headache of using open source, using OpenLDAP, but it's not nearly as big a headache as not using OpenLDAP. And as, of course, as with everything else, that is easier if you do it up front than it is to spend the months going back and making everything work with LDAP that you had. So, the next problem is configuration management. And that is, again, if you're running 200 computers, then you've got to manage configurations for all those computers. You have to manage the IPs. You have to manage the roles on those guys. You have to manage what software is installed on them, and all of those pieces. I think we need an open source tool to manage this. If it's out there, I don't know about it yet.
So there's a dozen different open source tools that combine those performance clustering world that you can use to do exactly that. 200 systems is a small cluster.
Okay. Well, then, what we have done so far is using an SVN repository. So what we do is we check in roles for each of these machines for the individual configurations, and then we can publish them out to the machines. That way we track them and version them. Speaking of that, I do recommend also naming by role and location. We started out being cutesy with our names at eMusic, and pretty soon it gets kind of old trying to remember exactly what Darth Vader does or exactly what location Trinity and Neo are the redundant routers for. We went with router01a.sjc, for example, for a router in San Jose, or wso3.nyc as a web server in New York City, that kind of thing. Although, obviously, developers are perfectly free to name their machine whatever they want. So, yes?
Do you have to use any session replication?
Any session replication?
Yeah.
Can you...
Okay, you said you have, let's say, 200 web servers.
Uh-huh.
And once the user logs in, the session gets established, right?
Yes.
And if the subsequent request hit the different node than the first one, how do you...
So, yes, so ideally, and that goes back to how you design your web services. Ideally, each of these systems, your overall web services architecture should be designed such that you do not have to have you do not have to maintain state directly on the web server. The conventional way to do that, obviously, is to store all that information in a session table in the database. Again, that gets back to a world where you have a centralized database that you can depend upon. In my experience, a lot of applications don't need that. One of the real traps that you can fall into is accidentally needing that. Because I've seen a couple of bugs over the years where everything works fine when the developer's doing it, because the developer's just hitting his machine again and again and again and again, and he was accidentally keeping some state on that machine without really being conscious of it. And then you roll it out to QA, and you actually have replicated the real production environment, and that's where you discover that, wait a minute, this thing didn't work because of that. If you do have an application where you absolutely positively have to keep state on the individual machine, you can do it with Apache and with the load balancers. You can configure the exactly right with the Linux virtual servers, but it does, to a certain extent, reduce your reliability from the standpoint that if that web server goes down now, you have to recover that session in some fashion. And so if it's at all possible to design it so that you don't need that feature, it's going to be more robust. Then the other big thing is management of third-party libraries and applications. When I first started doing software as a professional in the 90s, early 90s, there were two basic third-party things you had to deal with. There were operating systems and major programs, like databases, and there were libraries that were used by your application. I need a D there. The first one was pretty easy because you just set your current or minimum version requirement. You got to have Oracle 8 or whatever in order to do this. In the second case, it wasn't that big a deal because usually you had 2 or 3 of them. They were commercial. They cost a lot of money. They were updated once every 18 months. You checked them into the version control system. The VCS guy yelled at you because you shouldn't check binaries into the version control system, and you ignored him, and that was how you managed it. Right now, just from CPAN alone, I just pulled this number. At Vindicia, we have 97 CPAN packages that we distribute onto our web servers. Plus, there's the operating system, the base utilities, the libraries those CPAN packages need in order to actually function. And all that stuff's changing a lot more quickly than once every 18 months the way it used to. One possible solution to this is to take whatever tools your distribution comes with that lets you update these packages automatically. Okay? So maybe Yum under Red Hat, different things like that. The problem is, of course, that what happens when the library interface changes in an update, or what happens when somebody introduces a big bug. And the more and more and more of these things you have interacting, the more likely there are to be these subtle issues that you're not going to find unless you're going through some sort of a test process prior to doing the rollout. So you need some way to test all that stuff. Obviously, for more critical issues, security issues, you may have to follow a more expedited path. the more you think about it, the more you're a lot more like an operating system vendor than you are an application developer. Because you now have this set of packages that probably has a very large volume that you need to be able to make sure all works together. I'm going to go through two ways of solving this. One of them is the way that we did it, and the other is the way you can do it if you don't want to do it the way that we did it. I think the way we did it is a little less work. We use a tool called RPath, which is a bunch of ex-Red Hat developers who said, hey, you know, we could have done a better job on package management. And what they did was put together a bunch of tools to let you manage kind of your own distribution. You can update things online from a central repository, or you can run your own repository in order to build all that stuff, package it all yourself, make sure you have exactly the version that you think you do. You then take all that, you can build it into an ISO by role. And so you can say, this is the web server, this is the distribution of my OS for the web server, this is the distribution of my OS for the database server. If you're really good, you can actually configure Pixie boot server and make it so that these boxes are automatically installed when they come on the network. My dream one day is to get it to where I can tell a central server, the next machine you see is going to be a web server, and the web server will pull itself up and totally configure itself dynamically. I haven't gotten there yet, but that's what I want to do. Anyway, if you're doing any kind of appliance-like system, because one way of thinking about it is that you're kind of distributing your own internal appliances, I find their tools are very useful.
Is that open source?
Yes, it is with one provision, and that is, and like I say, it's a bunch of the Red Hat guys. The one thing that they don't let everybody do is that basically, if you want to check your stuff into your repository, excuse me, and not let anyone else get to it, then you have to buy a repository from them. But they run open repositories where you can check anything you want into it. And so if your product is open source, then it's totally open. But if you want to hold it yourself, then you have to buy a repository from them.
BitTorrent license.
Yes. So.
The keeper.
Now, obviously, apparently, there are things I don't know about configuration management. So there may also be other solutions. I think if you want to stick with your current distribution, not RPath, because I mean it is a distribution, then you've probably got to be taking your own packages, coming up with a system for tagging them, perhaps checking them into a version control system, and managing these packages yourself so that you have the possibility of saying, okay, you know, once a quarter we're going to go through, we're going to pull in all the major changes from each of these packages. We're going to run it through a QA cycle, and we're going to make sure there's no surprises out there before we do the run.
Sorry, I'm not following. So if you sort of said, geez, I want to be running SUSE
Yes.
on all my machines out there, you would not be able to use this to...
Yes, RPath is its own distribution. And so if you want to use SUSE or Ubuntu or Red Hat, then you're going to have to manage the packages yourself.
That's how all of these systems work.
Right.
RPath, FAI, all of them.
Right. Well, RPath, like I said, I mean, I know the guys there, and they have worked pretty hard on. Obviously, they're under a lot of pressure to make it work for Red Hat, because you know they go in and try to sell somebody, and they go, "Hey, why can't I use Red Hat with this?" But really, what it comes down to, what the difference between Red Hat and somebody else is the package management and the choice of packages, and so it really is kind of essential to the operating system. So. That is most of what I know about building these types of systems. I have about 10 years of experience doing it. I think that there is, I think that there are a lot of opportunities out there. I think that it's a lot cheaper way to do it than going with just off-the-shelf commercial software. I think that we get some new problems with it that we may not have with the other ones. But I think the new problems that we get are actually more interesting to manage than the old problems that we had, because the old problems were more about how do I manage my vendors and how do I get the money. And these problems are more about, you know, how do I utilize these tools as efficiently as I can. So, I guess, any questions?
Why would you choose Perl over Java or
Speaking personally, I mean, and I'll try and be as try and give you the pros and cons on it. Speaking personally, I think Perl is really fast for initial development. I think Perl has some potential weaknesses around, for example, maybe being a little too free-flowing with its class structure. I would like to see a little bit more of a way to constrain what classes you can do. Personally speaking, I use Perl because I've been using Perl every day for 10 years, and so that's a really easy choice for me to make. And I also just love CPAN. There is no other language that has any other, that has anything like it that I've ever heard of. Reasons you might want to use Java, you might prefer the greater rigor. I certainly think that for some developers, it's easier to have that kind of enforced rigor than it is the more freewheeling world of Perl. Honestly, you might be concerned about Perl's future. I mean, Perl, 5, 6 years ago, Perl looked like it was on its way up. I'm not sure it looks like it's quite as much on the way up as it used to be. I certainly want it to do well, but I can also tell you that I've been trying to hire Perl programmers, and I get an awful lot of Java resumes. One reason you might decide to go with Java is because you can't find, you're worried about finding enough people who can program in Perl. So, by the way, if anybody has any resumes,
But if you
I'd love to
go
hear
with
it.
Java, then you add more layers to your architecture.
Certainly, you're dealing with different tools. I personally don't have a lot of experience with, say running Java Tomcat under Apache. But obviously, a lot of people do manage to do it, so I'm going to assume that it's a basically workable solution.
So a few questions. So one is, so you make SOAP, in your current company, you make SOAP interfaces available for people to do from outside stuff.
Yes.
So a couple of things. One is, what do you talk about the interface, but what do you use for the payload itself?
So what we do is since we offer rebuilding solutions to companies, essentially what would happen is if you go to one of our merchants and you sign up for a product that is a subscription to something, then that merchant uses SOAP over SSL to communicate your payment details to us, what you purchased, what the term of contract is, that sort of thing. And then we store that in our system and we're able to do our billing based upon it.
And what is the communication? Do you use XML for the actual payload?
Yeah, well, so SOAP is the definition of that XML. So it's a definition of a way that data and function calls can be encoded into XML.
Right.
Okay? And generally speaking, each language is going to have a SOAP library that is going to translate between whatever their native mechanism is for handling function calls and handling data types and all of that, translate that into XML, and then transmit that as an HTTP post.
So, but the data itself is what? Is it in a class? Is it a
Yes. Yeah. So it is in a class, but it's a totally free-form class. So essentially, what you do is you just say, okay, I have name, I have name, and I have all these different text fields of address, and each of these has a particular type. And then I'm just going to take that and it encapsulates it into XML so that it is described by the names and the values and the types. UU encodes it, base64 encodes it if necessary, and then does an HTTP post in order to submit it. You also can theoretically do stuff like, you can do SOAP over email and different things like that, although I've never experimented with that.
And from the other end, from the user, from the partner companies, or whatever you call it, customers, any problems with getting them to be able to talk SOAP, or are they pretty up on it?
Well, so there's two ways we approach it. Again, I do want to be clear here that a lot of the value, I think, to me, of SOAP is not necessarily even outside of a particular company. I mean, a lot of companies have a need to go take data from point A to point B totally internally, and I think SOAP's a great solution for that too. What we do is we publish the WSDL, and so anyone who's using, say, Java can import the WSDL, and that generates their class libraries that they need in order to make all the calls pretty transparently. We also, as a service to our customers, write libraries in all of the major languages and platforms, which end up being only a couple thousand lines each. It's not too much work, but it allows a customer to hit the ground running and not even have to worry at all about, hey, how do I do SOAP in my language?
Now, another question. One of the other raps we hear about scripting languages is performance. You run into that? How do you deal with it? What kind of performance do you get?
Right. Well, so on the Perl side of things, the Perl performance problems that you tend to have, most of it, tends to come at your startup time. You can use mod Perl with SoapLight in order to compile yourself into Apache and avoid that startup time as every request comes. It's certainly not as fast as C. I have had experiences at eMusic. We actually had a mod Perl situation where we needed to run a whole bunch of servers on one machine, and we actually had to rewrite our Apache interface in C in order to reduce the fact that we had that 2 megabyte memory footprint from compiling Perl in per Apache instance. But my experience is that developing in Perl is so much faster compared to developing in, say, C, that the fact that you may end up having to buy 50% more web servers, which you're talking about going from 3 to 5, you're talking about spending an extra $5,000, really is not that much of a cost compared to hiring extra developers in order to make up the lost time.
And also fixing it when you run into a problem in real time a lot easier.
Yes, absolutely. Although, you know, once you get big enough, that can actually be a concern, you know, because it gets too easy to just hop on there and make a fix, you know. But yes, especially if you're a very small, very agile organization, that is a really wonderful thing.
So speaking of efficiency, so XML is famous for being perhaps one of the wordiest ways to express structured data.
Mm-hmm.
So is that ever annoy you, or again, is your manageable enough?
It is a problem that I have kind of brushed up against, I would say, where we do have occasionally people sending in these enormous messages, because one of the things we do is we actually help merchants with the chargeback problems, and so they'll send us all this, you know, thousands of transactions all at once to say, hey, you know, these transactions all got repudiated. And yeah, it takes a little while to chunk through all that XML and turn those guys back into objects. And I can certainly see applications where that might be a concern. It hasn't been a concern for me, and again, thus far anyway, it goes back to a very similar thing that, yeah, we could probably do it more efficiently, but we would have to write a lot more code to do it more efficiently. And the really nice thing about this is it gives us an RDO-defined open standard that's portable that everybody everywhere can use. So thus far, I found it to be well worth the trade-off.
You would never be caught dead putting XML objects into your database or anything like that?
No. So we have a whole other translation layer in Perl where we turn everything into database objects, and actually store it in a highly relational form that would be very difficult to deal with in Perl. So.
Actually, regarding your customers, I'm not sure whether there is such XML parser available in Perl, but some people are trying to create this streaming-based XML parser so that you can parse pretty big XML documents, so that you don't have to have everything.
Mm-hmm. Yeah, and actually, I will say that's a limitation that we have run into a little bit is, you know, where you might have applications where you'd really like to have the client and the server just keep the communications channel open and be constantly sending each other data back and forth. That may not be the easiest thing to do with just the off-the-shelf SoapLight tools. So.
Did you ever look at, instead of doing, you did it sort of the formal way, as I remember, having done something similar. But another suggestion I received once that I never actually did was just set up a very short time DNS, name each one of the web servers at the front, and then just have it hit them.
Right, try that. So round robin DNS on the.
It's not that even necessarily, well, it's round robin DNS, but it's also with some function of load balancing, because what you're doing is you're constantly basically pushing out alternate DNS tables.
Right. Yeah, well, and there's some applications that can be good for, because the example that I had up there of the way the architecture works, all the inbound and outbound traffic goes through the load balancers. And so, you know, once you get to a certain scale level, you start having problems of, you know, okay, I'm trying to push more out through the load. Since all of my web servers go through a single load balancer, that means that my traffic is limited to what a single load balancer can do, even though I may have all these web servers that are capable of doing more than that. And so that's one potential way to try and tackle that problem. I haven't had to tackle it yet. So.
Okay. It would seem that like eMusic would be more applicable.
Yes, yeah,
now,
exactly. No, in eMusic we were all about bits per second, and it's really funny. I mean, we were such a funny company there because people would talk about page views, and I'd be like, yeah, I mean, I get like, you know, we do like 10,000 page views a day or something. It's just, you know, really a trivial thing. Even by the standards of 7 years ago. But bits per second, that was what we really had to worry about. So.
You did say about database being a bottleneck. What are other bottlenecks you have deal with?
Every component is actually a potential bottleneck.
Oh, absolutely. Although the one place where it tends up not being is the web servers, because you have so many of them. Yeah, I mean, I think that you're right. I mean, I think that is what it comes down to. Like I said, we had the story at eMusic of the load balancer that ended up being a bottleneck, not based upon bits per second, but based upon number of connections, and that was difficult to diagnose. And we actually ended up, if you remember my slide, we had the music store back there, and so we had each web server would talk to the music store and copy the song off and have a cache of like 20 gigabytes worth of MP3s on the theory that what most people would be downloading would be the same. Once we realized that we had limited that load balancer, this was unfortunately not long after the bubble had burst, and we had absolutely no money. We had realized that we were not going to have enough money to make it as an independent company, and actually we ended up selling it to Universal, who then sold it back out to a group of private investors, and it's doing fine. Actually, it's the second biggest after iTunes. We actually we looked at it and we said, okay, we have to figure out how to solve this, but we don't have any money whatsoever to do it. And I sent Neil Overman, the guy who came up with Ralph, a way to come up with a solution. He came back and he said, we need to spend $20,000 on big IT load balancers. And I said, Neil, we don't have $200,000. We don't have $2,000. Like the way we get $200,000 is you tell me which 3 people we want to lay off to pay for it. So I actually had the idea, the Sun Enterprise 4500 there, and this was when I was alluding to us needing to rewrite part of the application in C. We took the Sun Enterprise 4500 and we just plugged it straight into the router and ran Apache on it. And we started out running Apache and Pro, and we were literally, everybody was down to Colo. We had to move all these boxes around because the network connection wasn't in the right place. And we did it, and the number of downloads just started going up and up and up and up and up because it'd been being held down. And everybody's doing high fives, and we're all just, yeah, we solved it. And Neil looks up and he says, we're running a memory on the Sun Enterprise 4500. I said, well, how much memory does it have? He said, 8 gigs. And I said, how much time do we have? And he said, 15 minutes. And so I said, put it back. And we put it all back the way it was. And then we went home and we rewrote, because the server didn't actually need to do very much to give out the songs. And so we rewrote that in C, because each of those Apache Mod Perl images took up 2 megabytes. We rewrote it in C, and each image took up 200 kilobytes. And we actually ran for a couple of years there, just serving every single MP3 straight off of this guy with no loud balancing, no nothing. And we were doing like 60, 70 megabits.
Yeah, I guess the other question I had was that you didn't actually, you may have done this, you didn't see to specialize your servers. So you didn't okay, images over here.
Yeah, we toyed about that. We toyed with that in eMusic, and I toyed with it here too. And I still keep coming down to, it's all just data, and it's like they all have to talk to the same stuff. And you do end up having, you usually end up having utility boxes off to the side, okay? Because there's always something you've got to do that doesn't involve talking to the outside world. But what that is going to come along with what your business is. Like for example, here at Vindicia, we have to take faxes. So I have a fax server that takes faxes in, and like that's a different thing. But I found, at least in my experience, it doesn't end up, if you had a business where you were doing 90% of one thing and 10% of another, maybe, but even so, that 10%, why not just run it all in the same boxes, And then that way you don't have to worry about, oh, wait a minute, do I have enough of that kind of server? So.
You weren't streaming music, so it would seem if you were streaming it might be more of an issue. Maybe. Architecture is.
Yeah, from my perspective, there's no difference. It's just bits.
Well,
from
the user's perspective, there is a difference. And
yeah.
It's a question of how fast the bits got there.
Yeah, but it still just comes down to a number of concurrent users, and you spread that all across it. Again, just my philosophy, but it's like every time I look at doing that, I keep saying, it's not worth the trouble because If I just put it out there, the load balancer will take care of it. So.
Do you have any experience with REST instead of SOAP?
With
REST as
no.
a new standard?
No, I don't. I don't. The only other experience I have in this kind of stuff is either stuff that we developed ourselves in the past, back before there were any standards on this. And actually, we do run XMLRPC using the same backend as we do SOAP. And so it's just literally, it's kind of like from a front-end perspective, it's the same stuff. We just do slightly different translation, and then we call the same functions on the back end. So, I mean, I think it's literally an extra 1,000 lines of code on our end in order to be able to support XMLRPC.
How about caching service? Caching, views, caching?
Not implicitly. I mean, in eMusic, we cache from the standpoint that we cache the MP3s at the web servers. I just, again, I haven't really ever seen too much of a need for that. I'll cache. I do think a very useful tool is to be able to cache data explicitly. So where you do stuff like say, okay, we have this data that's stored in this database that never changes. Rather than hitting the database, we're going to keep a copy of it locally and have some sort of publication mechanism. I think that's a very powerful tool for scalable systems.
I wonder that's security-wise, like obviously if you're a new company, it's probably get more aware of that. I was wondering, like, most of these laws and these new requirements, you have to, these auditors come in, they're probably
Yes.
wondering, well, you're running all the open source stuff, and you know, like, because a lot of them are more familiar with the sort of proprietary stuff.
Yes. Yeah,
I haven't,
absolutely.
like, sort of out of left
I-
questions that you can't answer.
I have a big grin on my face because that actually is a big personal problem for me. I will say I am a Qualys customer, a happy Qualys customer. I am since we run financial services, we have to comply with the payment card industry standard, PCI. We're PCI.
Virus scanners need to be there, but you're wondering.
Yeah, right, yeah. The one thing that is nice, PCI does not require virus scanners on like Linux servers. So like it's like they have some weasel wording around like systems that are known to be vulnerable to these sorts of attacks. I will say my biggest headache has been with Perl, convincing them, like they want to know what tool I'm using to make sure I don't have buffer overrun attacks. And it's like, there's no tool to prove that your Perl doesn't have buffer overruns because your Perl doesn't have buffer overruns because of the fact that it's in Perl. And I've had a similar one, SQL injection has been the big thing everybody's excited about. And they want to know what we're doing to prove that we don't have that problem. And it's like, we use Perl DVI with placeholders for everything. Like, we can't have that problem, you know? So, anyway, but yeah, that is a bit of an ongoing thing. I'm living proof that it is possible to do because we are PCI level 1 audited. Thankfully, we have some auditors who are reasonable and are willing to understand how things work. And we've gone to the mat a couple of times with Visa about our security policies because also you might imagine having worked at PGP, I like to think I know a little bit about encryption and security. And sometimes what I come up with isn't what their book says, and so it takes a lot of time to explain to them why what I came up with is better than what they think it should be. So.
But you then obviously get to talk to people who aren't just pointing at the book.
Yes, hopefully,
Okay.
hopefully,
Yeah.
yes. So we did finally lose on passwords, because I mean, personally speaking, I think it makes a lot of sense to generate everybody, 8-digit cryptographically random, out of dev random passwords, and like have you memorize it and use it for 2 years, and that is not their policy. Their policy is it must be changed every 90 days. And we're like, if we change it every 90 days, everybody has to write it down. So, and we lost that fight. So.
But it could be a weak password.
Yeah, no, they would rather have you have a weak password that changed every 90 days than a cryptographically random one. And if we look at the real attacks.
You can do both. You can have the 8-digit number and just tell them to increment the last digit.
Like have you seen the T-shirt with the DVD key?
Yeah.
It has the keys in sequence, all the keys preceding it, and then redacted, and then all the secret keys after it. One of the developers at work was burning that today.
Do you actually mean like
Yes, 8 characters. Yes, yes, yes. So alphabetic and numeric and all of that.
Did you run most pro on the Apache?
No, I have not. So when we first started Vindicia, I said, hey, new company, let's go to Apache 2. And I wrote the initial stuff. And I spent like several days trying to figure out why it wasn't working. And then I realized that mod Perl, it was like mod Perl 1.99 and it didn't actually work with Apache 2 right yet. And so I said, well, I don't have time to spend 3 months waiting for them to get it working. So I went back to 1.3. So we're still on 1.3 and I don't have any experience with that personally.
Are you still on 1.3? I'm sorry.
Yes, yeah, I'm still on 1.3. Because I mean, there hadn't been any driving need to get off of 1.3. I'm sure we will at some point.
Looking at really to explore new tools, that can save you time. So, have you explored anything we want to do?
No, I haven't yet. I will say. I'm interested in trying Ruby myself. I've heard good things about that. I find that personally, I tend to go through these cycles where it's like, I do a lot of head-down development work, which is what I've just been going through with Vindicia being about 4 years now. And then I'll spend some research time, and I have been in, I have to hit this deadline mode, not, hey, I wonder what new technologies are out there mode.
How many people do you have technical ones?
We have, we're up to 10 now, or 9, I guess, I'm sorry, in the development group, so that's including QA, so.
You have separated operations team?
Not yet. I will say, again, as you kind of may see, I'm kind of learning on the job. And this is the first time I've had to run now at eMusic we'd have a separate operations team. But this is the first time I've had to run operations that really focus on customers. And so that's, we're building the operations team. So we do have one guy that's the operations team. So that as we get bigger, that will become more formal. Okay. Anything else?
What's your opinion? So basically you said you basically creating one problem, going open source for another problem. So how is the business acceptance, overall, what do you feel about, this trade-off?
Well, I think it depends a lot on what your business is and who your business is. I can tell you that from my perspective, I'm CTO here and founder. I was all but a founder at eMusic. I'm obviously very interested in what the bottom line is and what the total bang for the buck is. I think that, if you look at, if I add up the money that I've spent over the past 10 years and what we've done with the money that I've spent over the past 10 years, what we've accomplished, it's inconceivable to me that not using this approach that you could have spent less than twice that, and you probably would have spent a lot more than twice that. As a businessman, as a technologist, I love this stuff anyway, but as a businessman, I'm very excited by the cost-performance ratio on it. Obviously, there are going to be businesses that are concerned about perception and concerned about what the way you do things is. And like I said, I just lost that fight with a big customer, and we got moved to Oracle, and so certainly that happens.
Well, thank you very much for an excellent presentation.